It is my distinct pleasure to introduce to you all a topic called version control. And the tool we're using for version control here is called Git. Now across the pond, Git is not a nice thing to call somebody, right? But it's just the name of a piece of software. That's all it is. It is a software for version control. All right, okay, well, what does version control mean? Version control means tracking, monitoring, and managing, and figuring out who made changes into a document. One version control system that you've likely seen before is version history on a Microsoft product, or on Google Docs, you might see track changes, right? On either one of those. Those are pretty powerful if you're working in a law office and you're tracking changes multiple authors on a contract, right? That's pretty good on a resume as well. But if we're talking about source code, hundreds, thousands of lines of source code, track changes is going to fall apart, right? And the most common version control system on planet Earth for people is naming files differently and using the file name to communicate the meaning. But that falls apart pretty quickly. If you say resume.pdf, then your second version is resume2.pdf, and then third version is resume final. And then finally, you have another resume called resume final before Monday interview final.pdf. I don't know if anybody has ever fallen into that one before. So that works for something like one document, but imagine how that would work for source code and software or in analytical projects, data science projects. So we're going to use a tool called Git. Git is a version control system. It was invented by the folks who were working on the Linux operating system as a way of tracking changes to the Linux operating system. And I'll give you the analogy definition. So Git is a permanent record for source code. Because source code is a set of facts, and we need to keep each set of facts different. The set of facts for version 1 is different than the set of facts for version 2 of a piece of software, right? And if you've ever updated an operating system or updated a video game where you get different version numbers, that's a version control system to keep track of things, right? So Git is a permanent record for our source code. Why do we care as data scientists? Well, we're not building mobile apps, we're not building web applications, but we are building applications that are dealing with data pipelines, and we are building applications that make inferences and that make predictions. So we're still writing source code, right? So Git's a permanent record. We're not going to spend too much time on the time machine part, but we do have a time machine of this permanent record of code. So we can go back in time to save points, essentially, for disaster recovery or for just making a different path. And to really blow your minds, we have the idea of parallel universes in Git. And this is just the analogy, the vocabulary word in Git is a branch. You might even see something called a tag. Version 1 would be a tag. Version 1.2 would be a separate tag, different set of facts. A lot of outfits have to keep multiple versions of software running at the same time. This happens everywhere. Point of sale systems, this happens with video games, all kinds of stuff. So the time machine and parallel universes, we're probably not going to use too much of those in the data science side. But if you have enough commits to your Git history, you do have a very rich time machine. And we can undo things or redo things. And basically, if you have enough commits, your work isn't going to go anywhere, even if your laptop goes for a swim in the river. I hope it doesn't. All right, so those are nice analogies, but what is Git actually? Here's your textbook definition, straight from the documentation. Git is a free and open source distributed version control system. Say that 5 times fast. Designed to handle everything from small to very large projects with speed and efficiency, which does. So Git is free to use. It is open source, meaning that we don't have to take some salesperson's word for it that Git does what it's supposed to do. And there's not a bunch of guys writing bad code in there. For the low price of reading the code, you can figure out what's in there. That's what open source means. The distributed part of version control means that we're not just tracking changes on one computer, not just your laptop. We're tracking changes on your source code, on your laptop, on a backup, on a desktop computer that you might be running that needs the same version. But the distributed part in reality comes into its highest and best use in group work. And this is something that is, so data science borrows a heck of a lot from software development best practices. This is something that you'll see in a lot of software courses or software boot camps, etc., but not necessarily data science courses. So this is a topic we have in here to get you the job ready. Specifically. Yeah, great. Yeah. When do we want, I'm going to repeat your question. Why do we need, or can I provide an example of different versions of code? One example could be A/B testing. You need 2 versions of code live so you can compare the control versus the test. Another version would be, or another reason why we might want to use branches, is we need to keep one branch of code current and add a new feature without changing the original code until that new feature is done and ready and squeaky clean. That's a very common example. Yeah. And also version 1 could be a branch, version 2 could be a branch, version 3 could be a branch. So you might need to run, you might need to run 2 versions of something at the same time. One version for clients in Mexico, one version for clients in the United States, right? Different source code for different reasons, different regulations, different laws. Yeah. Yeah, Jen.
I was going to ask on that. So is it a branch? Is it considered a branch to get file if someone adds on to someone else's post?
Not necessarily. Not necessarily. So the question for those of you at home was, if somebody adds work onto my history of work, does that necessarily make a new branch? And the short answer is no. So I'm going to show y'all, go code up. I'm going to show y'all the data science curriculum. I want to see under the hood of your data science curriculum? Cool. So we're looking at a repository. A repository is this is your first Git vocabulary word. Repository sounds really fancy. All it means is a plain old folder that is tracked by Git. That's what a repository is, a regular old folder, but Git is tracking the changes for us. And when we go into, so what's currently live on ds.codeup.com is this default branch called master. That's what's live right now. But we see here, we have various different efforts at different times. Some of this is very specific. Some of this you can see there's a branch called Ryan or Zach Spark. We try to name our branches what they are. So Zach Spark is some work that Zach did on the Spark curriculum. And ideally, or you can do one of 2 things. You can run branches independently or take the work from run branch and merge it in. That's a little bit more common. Now I realize I'm going around this way to answer your question, so let me see if I can be a bit more direct. We have, over the last about 3 years, almost 2,000 commits. So we have this permanent record. Check this out. Yesterday, Zach did work on the regression and the classification lesson plans. And you'll notice there's an alphanumeric that points to each commit. Are y'all ready for your second vocabulary word? Forget. Your second vocabulary word is a commit. A commit. Now, what the heck a commit is one or more changes to one or more files. That's it. And these one or more changes to one or more files could be one line to one file, or it could be we delete 1,000 lines of code from 10 different files. Git doesn't care about the size. So the first vocabulary word again is repo or repository. That's a Git enabled folder. That's it. The second word is a commit. And a commit is one or more changes to one or more files. And usually you want your commits to be related to each other, so they tell a story. So you'll see that earlier this week, or actually last week on the 23rd, I clarified exercise directions and did a pretty major Git curriculum revamp. So we're looking at the history for this, for the live curriculum, and you'll see that I made some changes last week that y'all are seeing now. So we see different contributors at different times across time. And right now, what we're looking at is one branch right here. So later in the course, y'all will be doing group work, and the easiest workflow, at least right now, is in that group work, everybody adds to the same branch. It's the easiest and simplest place to start. Yeah. So a commit is one or more changes to one or more files. And it's one or more changes to one or more files that's like, it's kind of like sealed in an envelope with a stamp from the cardinal. You ever see those, like an old movie where the cardinal signs an envelope with his stamp? And that's basically, that cardinal's, Bitcoin wallet, as opposed to and how much that's related to the individual. That's what these commits are. They're timestamped. They're cryptographically attributed to the author. So I have a high degree of confidence that some random person wasn't adding code to our source code. Right? So I know it was that. I know which places he did this. Cool. Did that answer the question of can we add onto a string? All right. I'm going to go on some asides from time to time based on your questions. So I want to make sure to come back to the center. Why should you care? Well, you should care because we never want to hear that your cat ate your homework in the classroom setting, nor on the job does anybody want to hear that the only copy of this work you've been working on for 7 days was your computer, and now it won't turn on because your cat knocked over some water. If you're committing multiple times a day, pushing multiple times a day, ooh, there's another keyword, a push. Get out your notes, get out your pens, folks. Here's a new vocabulary word, it's called push. So a push is an upload. It's an uploading of all of your commits. So a push is one or more commits you're uploading to a backup or to another computer. That's what a push is. The opposite of that would be a pull. If you were downloading work, like let's say Stephen and I are working on a project together. Stephen does new work and he says, hey, Ryan, I did that new work. I'm going to pull. And I pull things that are new to my computer. I push things that are new from me to the rest of the timeline. I'll hit that again. A push is one or more commits as part of an upload. That's what a push is.
So you have to consciously like push or change your GitHub. There aren't any like, let's say VS Code doesn't do it kind of for you, just actually have it.
No, you want to do this on purpose manually for a while because you're making snapshots of a permanent record. This is very different than like Dropbox, right? Or like your documents folder on a Mac that's always got a cloud backup for everything, right? Yeah, this isn't autosave. Yeah, it's very different. This is more like, instead of autosave, think of like a video game. Sometimes video games have autosave, but right before you fight the boss, you make a name save, right? Think of commits as name save. Or save games with a name. The names of your commits are going to be garbage. They're going to be these alphanumerics, which is why we add a little bit of English to each commit. And this right here is called the commit message. So in your notes, a commit message is an English explanation of what your commit is. Because to Git, all your commit is a alphanumeric identifier.
Question, so
Yes, Cindy.
you're showing us an example of all these commits.
Yeah,
Now, have you pushed them or have you had to push them to have them show up
yeah,
as well? or-
yeah. So Zach did these yesterday and pushed these changes yesterday. I did work the same day and pushed my work. And this is part of that distributed piece. We're both working on the same set of facts. And so we're uploading our new changes.
So if you did not push them, they would not show up here.
Bingo, bingo. Yeah, I'll repeat that. If you do not push your commits will only live on your laptop, which kind of nips teamwork in the bud. It also keeps you from backing your work up. So pushing is uploading your commits to a backup. We use GitHub, it's the market leader. And you're uploading your work / backing up your work that way. Yeah, Steve.
So if, let's say that you wanted to change the line about, I don't know, each different version, you wanted to say each different version.
Yeah.
And another version. How are those?
Usually chronologically and automatically. So let me repeat the question from Stephen. If I made a change on this sentence here, each different version of source code, if I changed the text here to versions plural with an S, I would have to commit that change and push that change to add it to the set of facts about this program. Unless somebody else on my team was touching the same line of code at the same time, everything stitches together automatically. Like you'll see in this history, Zach did work and I did work, but we were working on different things, so we didn't have any issues. Yeah. Yeah, let's keep going. Let's cover a little bit of more vocabulary here. The first two vocabulary words that I want to get from this list and into your mind is the concept of local and the concept of remote. The concept of local means the computer you're using right now. Your local could be a laptop, your local could be a desktop. If you were physically sitting in front of the server is the local, right? So think of whatever computer you're actually in front of as your local. Because Git is not just about tracking changes, it's about backing up those changes. We have this idea of a remote. And a remote means another computer or another server. And there are specific services out there, like a service called Github. Y'all have heard about that already. There are competitors to GitHub. It's not the only game in town. There's GitLab, there's there's Bitbucket from Atlassian. You can run your own Git server from your own server if you're kind of a systems administration kind of person. If you just get wild and crazy and want to run a Git server. Remote means another computer where you're pushing, you're uploading your changes. Okay. We talked about the word repository. It is a plain old folder that we've told Git to track. That's it. Your operating system does not know the difference between a folder and a repository. The only thing that knows the difference between a repository and a plain old folder is Git itself. So Git is not part of your operating system. It's an extra program on top of your operating system. Now there's not an icon for it, but it works from your terminal. So that's why we had to introduce the terminal first. I'm going to introduce two more vocabulary words, the idea of adding files in Git. Adding files is the step immediately before committing the files. So if we think about adding files as adding documents to an envelope. The envelope is not yet sealed. We can add one letter to an envelope. We can add 2 letters to an envelope, 1,000 letters. That's adding. Another term you might see for adding is called staging. So adding / staging are the same things. It means getting things ready and in the envelope. Now the commit is a formal save point. Once you make a commit, you have to give a commit message. When you make a commit, that commit is tied back to you as the author. Not a great idea if you're writing some wild, crazy manifesto to write it in version control, right? Because it's tying everything right back to you. But your commit is timestamped and it's cryptographically tied to you, right? And every commit is a snapshot at time. All it is one or more changes to one or more files. If that means you made 100 files, then you made 100 files for that commit. And then we talk about push. Push is pushing your commits to a remote. Pushing from your local to a remote in the cloud or another computer. And then there's a lot more vocabulary, but these are your fundamentals. And the last little fundamental here is cloning. Now, to clone a repository means to copy an entire folder from somewhere, but you are also copying the information, that meta information, that folder knows it's a repository. I see a hand up from Kate. Go ahead, Kate. What's on your mind?
I'm going to struggle to ask this right. Okay, so let's say you need to recommit this page that we're on right now. And let's say it's encoded in the backgrounds and the hyperlink's broken, like it was for one of the things earlier, right? Yeah. So you're working on that. You change that one line that's updating the hyperlink. However, Adam's also making a change 5 lines later. Is Git itself doing, I call it a kdiff because I've used that program, but doing a comparison of what's currently committed with what you are submitting versus what maybe Adam submitted 5 minutes before you?
Yeah, short answer, Git is paying attention to all of those timestamps, and it's going to do the best job that it can to stitch everything back together again in the right order. Now,
does it know what copy you're working off of? So again, in our timeline, there was what it is today, what Adam submits 5 minutes ago, and what you're about to submit. Does it know what copy you're working from, or is it just looking at the previous copies and again making that best guess?
It knows what I made the change to, so it knows the original state. This isn't a failure state, but here's where that can break down. Let's say at the end of a meeting, both Adam and I say, hey, we've got to make this change. And we forget to coordinate who's going to do the work. And we both make the change. Same line of code, same file, we both make a change. That introduces the idea called a conflict or a merge conflict. And what that is, it sounds kind of scary. It sounds like there's a problem with a word like conflict, right? But what that means, if Git is not going to overwrite either one of our work if it knows that both of our work is new. Both of our commits are new to its timeline. So in that case, I might be getting a little too far in the weeds, but I really like your question in the scenario. Scenario, 2 team members edit the same line 23 on the same file. Git doesn't know which to keep if we did the work at reasonably the same time. So if Adam has not yet committed and I have not yet committed, Git doesn't know which commit to go with automatically. So in the scenario, it creates a merge conflict instead of accidentally overwriting any one author's work. Now, what does a merge conflict mean? A merge conflict is a prompt to the human being on what stays versus what goes versus does everything stay from both. That's the scenario. Is that kind of what you're getting at, Kate?
Yes, but can I change the scenario just a bit?
Yeah.
So same situation, you guys leave the meeting and you decide you're going to do one line and he's going to do a different line. So you do line 23, he does line 25. You open the file at the same time. So you have the same base copy, but you submit your 23 line correction and your 25 line correction at different times. How does it accommodate for both those changes?
Oh, it's going to do its best to put Humpty Dumpty all in one piece with no problems. And it does a real good job of it. So let's say we have two team members needing to do edits. We'll say Adam edits line 25, and then Ryan edits line 72. What happens in this place? No conflict. There's no conflict at all. And because conflicts are the same line or lines, no conflict, Git merges everything together appropriately. So the order doesn't really matter. If Git sees Adam's work before mine, it adds the line 25. If it sees my work before Adam's, it lines up the line 72. The only place where this could be a problem is a Jupyter Notebook document. If we're text or SQL file or .py script, result. So it's merging all of those different changes on different lines. That's what it's quite literally built to do. The only reason why a Jupyter Notebook would be a problem here is that Jupyter Notebooks have a lot of metadata in them, a tremendous amount. It would be a little distracting for me to show that to you all right now. Did this articulate your scenario too accurately to what you were asking, Kate?
It does, and I think I'll have to see it to believe it.
I like that spirit. Cool. I think I saw another hand. I don't know if that was Jules or go ahead.
So just with that in mind, I know Jupyter is similar to the Google Colab, which is what we use for our 101. So I know you were talking about, for example, line 25 and line 72, but in that instance, in a lot of instances I've seen, you're building something on top of the other. Wouldn't that create a conflict because something isn't built for the line 25 is, line 72 depends on line 25 essentially, or the code that's there would depend on that. So doesn't that?
This isn't going to replace human communication.
Oh, okay.
Right? There's no shortcut for that. But if my line 2072 needs Adam's line 25, I might have to do the following scenario. Adam pushes his work to Git, then I pull his work, and then I do my work and I push my work. And it's this back and forth dance. And it doesn't really fall apart unless we touch the same file or the same lines in the same file. We can touch the same file, the same line, same file, or a Jupyter Notebook, because Jupyter Notebooks, they have so much metadata that it's not plain text. It's not like Python script or text.
Okay, thank you.
But yeah, that scenario, Jules, it happens all the time. I'll give you an example. I'm in the repository for the data science curriculum. Before I start doing any of my own work, this is my own workflow. This is what I did yesterday before adding stuff. I do a git pull to make sure that I get all the new work. And holy cow, it looks like Zach's been busy. So by pulling Zach's latest work, if I needed any of it, now it's downloaded in my computer with a git pull. And then I can open up, do work, and then commit and push my own work. So it's this ballet. It's a ballet, uploads and
You don't
downloads.
see him working on that code.
Oh.
Because you just see what he's done at that time.
I see what he's committed. Yeah, because commits are snapshots, like a save game. Now, this is where human communication comes in. If he's doing a major change to a bunch of curriculum, we need to be on the same sheet of music, right? But see how he's doing stuff inside of a Zach folder. He can do stuff in a Zach folder all day long. I'm going to do stuff in other folders, and we're not going to have any collisions.
I was thinking about if you're like working remote and you're working with somebody. That could-
We're not seeing, like, I'm not seeing him type code. It's not a live thing, but
You have to literally get in contact with them and say, okay, you're working, stop, save yours, and then I'll work from there.
only if we're touching the same lines on the same file. But if he's doing his work, I'm doing my work, and it's on different files, different lines of the same files, we're not going to have any problems. We do this all day long. We do this week in, week out. Not just on the data science curriculum, but on large pieces of software. Right? And our curriculum is a piece of software. It's a deployed website, and all of the Python code in our curriculum is syntactically correct. We know that it runs. It's not just text. We actually write Python code and then we run it through a validator. It's pretty cool. So yeah, that's a little bit of the workflow. These are great questions. Oh, wonderful. Now is the part of the episode where I want to demonstrate building a repository and then getting some work into that repository. I do see some questions and I want to prioritize those questions. I think I saw Cody's hand first, and I think I saw V. Go ahead, Cody.
Sorry, what was that?
I see your hand. Do you have a question?
Oh yeah. So if you make a clone, is that clone automatically updated, or is that something you have to go in and reclone or force updates into?
No, a clone is a copy of everything at that one state of time. Short answer, no. This isn't Dropbox. This isn't Google Cloud or Google Drive or Apple iCloud. So we're not talking autosave or auto backups, which makes it seem kind of old-timey compared to what everybody's used to. But you don't want a lot of autosaves when you're talking about source code, right? You want autosaves locally in your source code, but like the website that's running right now is built off of the source code. So I don't want to change that source code unless I'm doing it on purpose. Okay. Cody, did that answer your question? Awesome. I think V had a question.
Is GitHub a good example for where we would pull our CSVs from if we got it to work?
If you were where you would pull your CSVs from?
Or big data, would big data be stored on GitHub?
Not really. There's tons of data on GitHub, but there's we're not using GitHub as long-term storage for pure data. Usually, I'll say this, Git commits, I believe, file size is limited to either 50 or 100 megs. Yeah, so this isn't going to be where you get a bunch of big data. That being said, lots of people jam a lot of data on GitHub. It's just not the best idea in the world. Yeah, did that answer your question? Cool. Cool.
This is not backup databases. This is solely for our programs or code, and we then be pulling a separate SQL database.
Yeah. So Git is tracking line changes in files.
Okay.
And does that mean you can save images and videos and whatever else as long as it's less than the limit? Yes, it does. But that's not how we're building our castles, really. Git is tracking line by line changes in however many files we have. Because even if you're compiling source code, like building an exe or something like that, there's still code somewhere, lines of code. And even images are just lines of code in a way. So yeah, Git is tracking line changes in files by line, and it is not a database. So yeah, that's a true statement. That's a true statement, Andrew. Awesome. These are fabulous questions. All right. I'm going to give y'all the opportunity to determine your own fate. Choose your own adventure. Would you like to see me make a repository and go through a kind of a toy workflow? Or would you like me to do a toy workflow while you have a flow chart in front of you? Your call. Flow chart in front of you. All right, here's what we're going to do. For our folks at home, I'm going to go to Google Classroom and hit publish on a thing. For the folks in person here, I'm going to hand out a handout. If I can find it. All right, here we go. This is brand new content to the curriculum, so enjoy. Google Classroom is sending y'all out 2 different PDFs. I'm going to take a moment and share these PDFs with our folks in person. Yeah. 1, 2, 3, 4, 5. 4. 5. Yeah, if you'll help me with that side, one of these for everybody. Yeah, thank you very much, Arthur. And then for you all, one of these for everybody, one of those for everybody. Thank you for your help. Okay, so
That's too long. You're about to drink water. I was about to drink water.
that's one way to hydrate. Don't waterboard yourself. All right, I'm going to give you all the cliff notes here. I realize I just gave you a handout that tries to simplify things. We have 2 workflows. Initial setup workflow. And then we have our regular workflow. Thank you, Jason. I realize we are at the 70-minute mark. Y'all want a little bio break before we get into the finer details here. Yeah, a little bio break, cool. If you're like chomping at the bit, read through that diagram. If you need to like hydrate, use the restroom, stretch your legs, rest your eyes, do that. Let's come back at 2:50. You beat the rush.
I did. This might be a good time.
Yeah. Nice thing. Oh, my hand's already broadcast. Oh, there you go. Let's say from start to go somewhere like I can go. Every now and then you see
All right, so we're talking about our two workflows. Our first workflow is to set up a repository. And if you've done this kind of thing before, you know that there's two ways of doing this. I'm going to give you one way because it's simpler. I'm going to give you the simple way. So here's how to make a new repository on GitHub and set it up on your laptop. Okay. So without further ado, I'm going to go to github.com. And we can do one of two things. I can go to github.com/new, or I can hit this handy dandy little plus sign on the upper right-hand side, github.com/new, or click the little button that says new repository. Remembering that repositories are only regular old folders that Git is paying attention to. So let's talk about this page right here. We are going to make a brand new repository on GitHub. So GitHub is a hosting service. I'm associating this with my personal account. If you are working with an organization or a corporation, there might be a company account, there might be some other accounts. Just for right now, keep it simple. And for my repository name, just for demonstration purposes, I'm going to call this my first repo, which is totally aligned, right? In this first repo, I'm going to say, hello world. This is an example repo. So we need a repo name, and you're going to notice you can't just put spaces in a repo name. This isn't just code up instructors that are like, get rid of spaces in your folders. It's like the industry, anything that touches the web, basically. Right, so my first repo. And then I give a description. And then I'm going to ignore everything else. We keep the visibility public, and we're going to skip all these check marks and click create repository. That's it, name it and description. Okay. Linda, will you do me a favor? See if Arsene wants to join us. Awesome. So once you've gone to github.com/new and made a new repository, let's go back to our workflow chart here. The thing that I just did was step one. I kept visibility public because we want you to build a public portfolio until the company pays you money to keep your code private, right? That's step one. Step two, you click on the SSH button and then copy what's called the clone address here. So you copy that to your clipboard. There's a nice little button for it on the right hand side. Oh, well, you should probably add an SSH key. That would be a stumbling block. I thought I don't think we audited everybody's setup on that. Let me run through this as a watch me, and then I'll get with you. Oh, yeah. If anybody needs help with adding an SSH key, please let me know. Now is the day to get that set up, because it'll help us the rest of the course. Yeah, thank you for that, Angelo. I misunderstood your comment. So you're going to copy that address, and then the address, notice HTTP looks like a web address, doesn't it? Well, SSH is a web protocol, but it's more secure than HTTPS. In fact, it's more secure than a bank's website. It's pretty cool. So copy the git@github.com. You'll see your username, you'll see your new repo, and check this out. We just did step 2. Now I'm going to do step 3. I'm going to go to my projects folder. Currently, I have nothing in my projects folder. Step 3 here is to type git clone. And remember, clone is a copy. You're making a wholesale copy of a repository, including the fact that that folder is a repository. And check this out. So what I've done, I've made a blank empty repository on GitHub. And now I copied a blank empty repository down to my computer. I even get a warning about it. You've cloned an empty repo. And ls now shows us the following. where my projects folder was empty, I now have a new repository called my first repo. As far as your file system is concerned, a repo is a directory. Your Apple doesn't know the difference, like the software developers do, but the operating system doesn't know the difference. And you'll change directories into that example repo. And we'll walk you through this on your own. I want to do the demo first. Okay? So I made a new repo on GitHub. I grabbed the clone address. I went to my own parent folder where I want to put this project. I cloned this, and now we see that my first repo is added as a folder, and now I've changed directories inside of it. ls, if I do an lsla, I want to show you something. The way that Git knows which folders to track and which folders not to track is a function of this hidden folder called .git. You'll see that there. That's the only way that Git knows if a regular old folder is supposed to be part of its responsibility to track or not. Now, the contents of that Git folder, you don't want to mess with or touch because they're all internals. But if you do an lsla, and remembering our command line flags, the A shows hidden folders, right? The L shows things in a list. Once we've cloned this repo, we can also check the Git status, and we see that I'm on the branch called main. That's a good default branch name. No commits yet, nothing to commit. Because it's, other than the Git internals, this is an empty folder, it's an empty repo. I'm gonna pause real quick. How are we doing so far? Yeah, that's right.
So where it's the flow chart is not Git, like a piece where we type. Like it's like LSLA will show you folder.
LSLA shows the empty folder, and then Git status shows an empty repo.
Or I guess also there's a where would you go to that is not Git, I guess it's that would be under LS.
The name of the repository you cloned. One sec. It helps if I had my own handout in front of me, right? Yeah, you see where at the very bottom where it says CD new project? That's what I did to move into my first repo folder. And then LSLA shows that it's empty other than the Git folder. And the Git status, if you do Git status anywhere else, Git's going to say this is not a repo.
That document file is where that's what tells whether or not to find it.
Right, and that's all under the hood stuff. Yeah. Yeah. Lincoln, go ahead.
I'm getting my permission at 9 and then public key.
Okay, do we troubleshoot after the demo? Okay. I know you want to keep up, but
It's fine.
it won't take us long. Yeah. Okay. Other orientation questions. I'm going to check the chat with our friends online. Okay, cool. So to recap, I am in, if I go cd ... I'm in just some plain projects folder. Plain old projects is not a Git repository. It's just a folder. But because I cloned a repo called my first repo, it is a repository. And it's not doing anything yet for us, right? So now it's time to do some work. I don't think I have VS Code installed. Okay, I don't have VS Code installed. I'm going to do some work with, I'm going to make a Python script. And I'm going to say print, hello, Jemison. That's my Python program. ls shows that hello.py now exists inside of this folder. Git status. So now you're starting to use your first Git commands. The very first Git command we used was git clone. Now I'm going to check the status. So check this out. Git is saying you're on the main branch. There's no commits yet. There are files in this folder that I am not tracking because you have not told me to track them. That's what that means. So we're right in the middle of that first time setup. We made a single file. Now I did get status. Now I realize the handout says example.txt. I made a Python script. So now what I'm going to do is this process of telling Git to pay attention to this file with git add and then the file name. And check out what happens after I tell. So I tell Git to pay attention to hello.py with git add hello.py. And I type git status. And what we see is this green. Green means addition, red means a deletion, right? Or an untracked. And we see that there are changes to be committed. So we have things in the envelope, but we have not yet sealed the envelope, nor have we sent the envelope upload. Once we've added a file, then we're going to make a commit. And an example here, this is kind of around the bend on the last little piece here. Git commit -m. The -m is for a message. It allows you to add quotes. And I will say in here, add hello script. So you you type in English what you're adding and why. Let's do another git status for good measure. Okay. And then so you remember that long chain of commits I showed you on GitHub earlier? Git log is the way of showing those string of commits locally. So what I'm sitting on here, I'll hit enter a couple of times to move the text up higher. Author, me, timestamp. Right, you'll even see the -500. That's accounting for time zones. And then add hello script. And now when I do a git push, don't remember what push is? Upload. I'm uploading my commit to GitHub. So if my Wi-Fi had been out when I typed git push, we would have gotten an error that the upload did not complete. Check this out. We did finish the upload. Back to the repository in GitHub, the web page for this repo, and I refresh, and you see a Python script there. If I run this Python script, it doesn't change the source code for that Python script, right? If I change the source code for the Python script, we're going to have to add it, commit it, and push it to have that script backed up. And that part is our daily workflow. Okay, so daily workflow is pretty simple. You do work, then you add that work, you commit the work, and you push the work. Lather, rinse, repeat. So let me do the daily workflow. Let's say instead of hello Jemison, I want to change the functionality of this program. This is a simple program, right? I'm going to change the source code. And I'm going to say, what is your name? And then down here, I will say, hello. So I'm changing the code a little bit. Don't get hung up on the Python here. It's pretty evident what it's doing. Let's check our work. What's your name? It's Ryan. I should say hello, Ryan. Nothing too crazy. But now we check Git status. So we did work. Doing work, as far as Git is concerned, you could add a file, delete a file, rename a file, delete lines, add lines, delete 10 files, delete everything. Those are all changes that can be added to a commit. Because all a commit is one or more changes to one or more files. And even deletions of deleting a file is a new fact about that file. So in this space, we did work. Now it's time to add the work. We could do one of two things to add the work. We could type git add and then the file name. And then here's something you'll see a lot more commonly. If you touched multiple files or modified multiple files, instead of just adding the file name, we could add the period, which says this here folder and everything in it. It's a nice little shortcut. Git status shows us changes to be committed. So we see new stuff in the envelope. And now in new git commit, we'll say git commit -m, and we'll say add feature to prompt user for their name. Git log shows 2 commits locally. Now remotely, I only have 1 commit. Why do I have 2 commits on my laptop, but only 1 commit on GitHub? I didn't push, because this isn't automatically linked, right? This is built on, we make software deliberately, not just, whatever, autosave everything, right? We want to be very deliberate here. So you're absolutely correct, Fred. I heard a couple other people say, you got to push it. I believe it was Salt and Pepper wrote a song about this very thing. So we push, and then we refresh the browser. We see 2 commits. First commit was adding the hello script. Second commit was changing the work. And what we just went through was the second handout, the regular Git workflow. Do work, whatever it is, add it, commit it, push it. Do work, add it, commit it, push it. Lather, rinse, repeat. We are committing and pushing at least 2 times a day in the classroom space. I'd say at a minimum before lunch and before you head home. If you're typing out like 100 commits a day, you're actually just wasting time. But if you're doing anything less than 1 or 2 commits a day, you're putting your code in danger. Because it's that one day you forget to push and your laptop falls out of the backpack. And that's yeah, Angelo.
Yes, if you look at the diagram, and I was along here, I could just continuously either add or change files to my folder, but it doesn't look bad until I push that one time. I can push it constantly.
Correct.
I guess.
The pushing is the upload, is the backup. So if I could do a week's worth of work without pushing it, I'd probably get hives from my nerves about doing that. But until you push your work, it's not going to live anywhere else but your computer, but the local. You may have noticed that I pushed 1 commit at a time here for demonstration purposes. Usually we make commits like once we finish a thing, finish an idea or a piece of documentation, a bit of analysis, something identifiable at the save point. But if I had 2, 3, 4, 5, 10 commits, 100 commits, and then I push them, they would all go in that one upload. Because push pushes any commits that have not yet been pushed.
So you have let's look at 10 different files so far. You did add period. And we did get commit all the way to the git push part. We didn't count each and every single one of those files as a single commit for the entire push point.
Look, let me repeat that scenario back for our folks at home. This is a great question, D'Angelo. D'Angelo is asking, hey, if I do a bunch of extra work, and we do not just hello.py, but say we do we add like a README. And in that README, this is an example repo. And then I add a license. Source, I don't have legal license stuff in front of me, license text. So D'Angelo's setup was, Brian, what if you do work on multiple files? If I add both of these files to the same commit, that same commit will hold changes to 1, 2, 10, 100 files. We don't want to jam too much work into one commit because then we don't have a chain of time. But if these two things are pretty closely related, I don't need to track README separately from the license. Those are both kind of helper things. I can add them together. And then Git status shows me these two different files and their changes are going into the envelope when you seal them with a commit. And I'll do a commit and I'll say add README, add license. And then when I push, check out how the push pushes that third commit, but that third commit touched two files, is what we're seeing here.
One final question. So when you did the commit, type in both. After typing in both names, or is there a way kind of like to add all files? Is there any way that you can only type in one simple?
Oh. We have a shortcut with git add period that adds any unadded changes. So new files, deleted files, or changes of files. But this is a pretty blunt tool when you say everything in my folder. So I want to get y'all to a comfortable place with Git before I tell you like to not do certain things. But if you were working on two different chunks of work that were separate, I would avoid adding them to the same commit. You would add them by the file name.
That answers the good question.
Okay.
Commit here, type in.
Right here.
We add README and license. Did you have to type that for both of the name README and license, or is that just the name?
This is just English.
Oh,
That's just English part.
okay, then that's fine.
Yeah, whatever I write in here, I could say just add stuff. But if you're telling a story, your commit should tell a story. If the story is add stuff, add stuff, add stuff, add stuff, your commits don't tell you anything. But yeah, this part is my choice. Yeah, I could have just said add metadata, because that's a description. You can't make a commit without a commit message, though. Yeah, I see. I think Jen had her hand up a little while ago.
Some of it went on it, but just to clarify, so we can't
Uh-huh. Yeah. Uh-huh.
That is adding to the folder itself, right?
That's adding any changes. So if there are no changes, right? If git status is clean, git add period doesn't do anything. Yeah. But if, let's say I removed README and I removed hello and I removed the license, git status shows that those are deleted. The file system sees that they're deleted. And here, git add period would add the fact that I deleted all three. To one commit.
After the fact.
And then after the fact, we would push. So let's do it. I don't think I can put an exclamation mark in there. Git add. So git add made everything green. I know it's kind of weird to think of deleting things as actually you're adding the fact that you deleted things. But we see this in accounting. I don't know how many of y'all have taken an accounting class where on an accounting ledger, even if you make a mistake, you don't erase the mistake. The next line says that there was a mistake on the previous line. Same deal with Git. Git's a statement of facts. So here I would say, nuke everything. And then I can push it. And now we pushed the fact that we deleted everything. I know that seems like we just went through a bunch of work for nothing, but what we see here is an empty repository on GitHub, but its history is rich and has everything we need. So if we wanted to go back in time, we could. We could even go back to the very beginning of time and say, I just want this hello script. Things got crazy. I made some other crazy program and then I nuked everything. This is the real reason why commits are valuable. You don't get this kind of clarity with autosaves or track changes, not really. Yeah, but Jen, did that answer your question?
Yeah.
Right, I think Andrew had you in the queue.
So I have two questions.
Yeah.
Is there anything you would do between a commit and a push? Like why you wouldn't just push immediately right after commit? Why is it two separate commands?
In case I wasn't completely done working on that thing, like let's say you had a job to do A and B tasks on a file, I would do the A task, make a commit, and unless I needed to change my workflow for some reason, I would do B task. Like if I had a focus time, I'd do B task, commit B task, and then push them. Yeah.
So my second thing is that if you're committing more than one file, if you're adding more than one file at the same time, that's going to be commented in one line. There's no way to send you separate comments for that for those separate files.
Not without committing them separately.
Okay, so you would need to commit it separately.
Yeah.
Okay.
So generally, I will sometimes make a commit with 5, 10 files, but that one commit, all of those 5 or 10 files are related to the same project. Like, I'll give you the real example. In this curriculum here, I changed text, I changed pictures, I added diagrams, I changed links, and I also uploaded those pictures. So that was a whole bunch of files. So they were one commit.
Right, because it was focused on
One specific thing.
Gotcha.
Yeah, that's really a best practice workflow kind of thing. Yeah. Great.
Real quick, did you say you can't commit without a comment?
You cannot commit without a comment. Yeah, I'll demonstrate. Let's remake a file. I'm going to make a file called hello.txt. I'll say, hi, everybody. I'm going to save my work. ls shows me hello exists. Git status shows me that hello.txt Git doesn't know anything about, so I can add it. But if I try to, the best way to show this to you is to type git commit just on its own instead of the -m. This brings up your editor. We ran a command in the setup to set up VS Code as your default editor for Git. If I just close this, the commit never happened. So we'll try that again. If I try the commit and I say added stuff, and I closed it and didn't save it, same thing. No commit. So if I commit and I say add stuff, save it, Command S, close it. Now we're ahead by one commit. So yeah, you can't make a commit without a message. The challenge there is that gets in people's way. So sometimes they'll leave a generic message like added stuff. But then if you do that 3, 5 times, 10 times in a row, you kind of destroy the semantics of that, right? And then we'll push the commit. There we go. So we had a roller coaster story. I added a script. I changed the script to implement new features. I added a license and a README, then I deleted everything, and then I added more stuff. It's been a wild journey with y'all. I know we just started together. It's been a wild journey. Love it. And that's really the workflow. The only time this is going to change is if I have a catastrophic issue, like getting a new laptop. If you get a new laptop, what do? Let's pretend that I'm on a brand new computer. And hopefully have just enough battery for this. So on a brand new computer or another computer, if I want all of this work that I did, and we do this all the time, not only do I want the hello.txt on the new computer, I want that chain. I want the history of everything too. That's the purpose of a repo. Here's how you do it. You go to code, green little code button, copy the Git address, Git clone, paste it. You see what's going to go on here is wherever you clone becomes the parent folder of that repository. So y'all are going to have a folder on your desktop, not your desktop, your home called Code of Data Science, and you're going to jam every repository in. Something we want to avoid is repos inside of repos. So we do want to avoid that unless you're really comfortable. And now I have all that work back. Not only do I have all of my work back, I have the play-by-play of every commit back. And that's really what a clone gives us. I'm gonna grab my charger real quick. Think about it. Question B. Oh, wonderful. I don't see why it didn't show me the hand. Thank you for saying something, B. Hey, looks like you've got a question. How can I help?
Yeah, you touched a little bit on this with someone's in-class question about going from commit to push, but why, can you give some just general examples of when you'd save but not add, and when you'd add but not commit? Like, when would you pause there?
Oh, when you're not done with your work.
Done being because I'm going to lunch, or done being because I haven't completed a section of code?
Could be both. I've done temporal commits, like I'll commit even if something's not done, just to have that save space, just to have a hard save point. Usually you want to commit when you finish a thing.
And can you uncommit something? Does that make sense?
The short answer, yes. Short answer, yes. You can rewrite history. I don't really want to get too much into that, but it's possible. That would happen, like if you accidentally committed something with a password in it, I would absolutely want to help you rewrite that history and then change that password in every system touched, right? When would we add but not commit? I would say I add things and I might check with myself, do I want to make this a hard save point? If yes, commit. If no, if I still might do some work after lunch, I might just keep on adding on it. Yeah.
And then on a related note, I can see that we can do all this in command prompts, but is there not a GUI for this?
There's not a GUI for, when you say this, you mean Git?
Yeah.
There is a desktop GUI. There is a Git desktop client or a GitHub desktop client, and there's a couple of other competitors. I've been burned by GUIs that talk Git commands in the past, so I stick to the terminal commands because that's what those GUIs are actually executing underneath the hood. But if you want to use a GUI like GitHub Desktop, knock yourself out. You have my encouragement, but I will support command line commands. Does that work? Yeah, there's a whole bunch of like Git clients, desktop clients, because folks love GUIs, right? There's a GitHub Desktop. There's a program called Git Kraken, which is a desktop application. I've not been impressed by any graphical user interfaces for Git, but I'm kind of a grumpy old man, so take that with a grain of salt. Let's check in with the curriculum. Permanent record for source code, time machine, parallel universes, and we're backing up all of our work every day. We walk through, and I've got some very detailed directions in the curriculum on that first time setup, with screenshots and stuff. And then we work through the regular workflow. I mean, here's what's going to happen. As you do work in Git every day, your GitHub profile starts to resemble a GitHub profile of a data scientist, right? And you'll see down in these green boxes on this contribution chart, you get an idea for how much people are working on stuff. So each one of these green dots represents a commit, and the shade is how many commits I made in that day. And this is a way that hiring managers and technical folks are going to check you out before talking to you, right? We'll check out your GitHub because it's at the top of your resume. And they will judge you. They want to make sure you know how to work this, right? So let's see. So Pepper did the song about pushing with Git. Snoop Dogg puts it best, Git push every day. Git push every day, really and truly. That will be an actual grade component that we will grade on is pushing every day, unless we have like a 4-day week, right? And unless we're in the Tableau lessons, because Tableau wouldn't get that talk. I wish they did, but they don't. Okay, so where are we again? What have we talked about? We went through creating a repository on GitHub and then down to your computer. So cloning that repository from GitHub to your computer. Then we talked about regularly adding, committing, and pushing work. Now this clone a repo first way of setting up a repository, this is an opinionated way of getting started. It saves you a couple of steps versus creating the repository locally first. We have a link to that in the appendix in case you want to do the same thing with more steps. And then later in the course, we will work through Git teamwork. But don't worry about that yet. We got to make sure each one of them is good. Making repos every time we start a new module, making repos every time we start a new project, adding, committing, and pushing every day, adding, committing, and pushing every day, adding, committing. Right? I do have some reference material on configuring GitHub and some text on how to set that up, and also how to set up something called a git ignore file. A git ignore file is how we say, hey, git, ignore this file or ignore these files. This happens with data sets. So in case we don't want to add multiple gigs or hundreds of megs of a data set, we ignore the data set so we don't accidentally try to commit it. And let's see, it's 3:31. I'm very happy to take your questions, although the best way to learn this stuff is hands-on. So I would take any and all GitHub questions you have, especially if it says anything about a key or anything else. I want to help you with that. And then we'll start with these exercises right here, starting with these configuration setup exercises. Okay. Are you ready to get on the field? All right, let's get on the field.